So evaluate the given expression over here, which is very important from calculus. This comes from the definition of the derivative. So in first semester calculus, we use this idea quite a bit. And evaluate this for this function over here. So first of all, substitute 3 plus h in for this x right here. So it's going to be 2 over the square root, and then substitute a 3 plus h, and then there's still a plus 5 in there. Now substitute a 3 into the function and subtract those two fractions. And then the denominator for the whole thing is this h. So I can combine the 3 and the 5. So there's 2 over the square root of h plus 8 minus 2 over the square root of 8. So I could rewrite the square root of 8 as 2 radical 2, but I can't really do that over here because of the plus h. So I'm just going to leave this as a square root of 8 for now. If I need to reduce it, I'll do that at the end. The next problem I have is that I've got a compound fraction. I've got this overall fraction that has h in the denominator, and then I've got fractions within fractions. So I'm going to use the least common denominator, which is this square root of h plus 8 multiplied with the square root of 8. And I'm going to multiply that on the numerator and the denominator. So multiply the numerator by the square root of 8 and the square root of 8 plus h, the square root of 8, the square root of 8 plus h. So for the denominator, that's just going to be everything multiplied together. And for the numerator, then distribute. So this is going to be multiplied here and here. When I multiply it with this one, the h plus 8 in square root and 8 plus h in square root are going to cancel each other out. It's going to leave only the 2 and the square root of 8. And then it's no longer a fraction. Likewise, when I multiply this one over here, the square root of 8's are going to cancel, so it's only going to leave negative 2 and the square root of 8 plus h. Because of this subtraction in between, these cannot cancel, and these cannot cancel, only if they showed up in everything, as well as the 2's. If there happened to be a 2 here in the denominator, then we could cancel all the 2's in all three places. But as of yet, we can't cancel. Well, the next idea is, if I were to get rid of the square root, I would have 2 times 8, and over here I'd have 2 times 8, but subtracting. They would then cancel. So I want to get rid of those square roots. The way to do that is multiply with the conjugate. That is, use the same expressions, but with a plus in between instead of a minus. And whatever you multiply the bottom by, or excuse me, the top by, you have to multiply the bottom by as well. So use the conjugate 2 radical 8 plus 2 radical 8 plus h. And for the denominator, don't multiply it out, don't distribute, but just write down the whole string all multiplied together. So the denominator now has an 8, an h, a square root of 8, a square root of 8 plus h, and then multiplied with that, and just leave it in parentheses, is this conjugate of the numerator. All right, now distribute over here. So we need this one times this one, which is going to be a 4 times an 8. And now the radical's gone. 4 times an 8 with no radical. The middle terms, this with a negative 2 times a positive 2 and those two radicals, it's the same as this. So the inner and the outer ones are going to be the same except opposite signs. So they cancel. So really the only other thing we need is this times this. So that's going to be a positive 2 times a negative 2. And then an 8 plus h with no more square root. And then finally we've got things that are going to cancel. So distribute here. There's going to be a positive 32, subtract a 32. So those are gone. There's going to be a negative 4 times h. And the numerator is simplified very nicely. And for the denominator, there's the h, there's the square root stuff. And then, in the end, there's one more thing that we can cancel, and that is, now that this is one term, and this all glued together is one term, now we can cancel the h's. And so finally, we've got the answer negative 4 over all of these square roots. And there it is, simplified. And if this was calculus, the next thing we would do is have h go to 0.